Hello, this is the first video of a fifth calculus series for OCR Pure Core Further Mathematics and provides an introduction to volumes of revolution. You have probably already come across the idea of splitting areas into strips or rectangles in order to estimate the area. In these diagrams you can see an example where first of all we have only used 5 rectangles. Delta x is 0.4 and the area is estimated using the sigma notation for summing between I equals 1 to 5 the height of the curve f of x times the width of the rectangle delta x. In the second diagram we have increased the number of strips to 20 and delta x has reduced accordingly. You can see that would give a more accurate estimate of the area. Integration is the limiting process where the sum of rectangular areas is used as an approximation to the area under the curve. And as we can see, as the rectangle widths become smaller and hence more of them are needed, the approximation from the area becomes far more accurate. So we have estimated the area by summing small rectangular areas, which in effect are the height of a rectangle f of x times the width of a rectangle delta x. But in the limit, as delta x tends to 0, in other words we have an infinite number of strips, then the sigma notation is replaced by the integration notation that we are used to. You can see here we are estimating the area between x equals a and x equals b, between the curve f of x and the x-axis. We now wish to extend this idea. Imagine a curve f of x and rotating it around the x-axis. It would create a three-dimensional solid or volume of revolution. So each rectangle of height f of x and width delta x, when rotated, would form a cylindrical disk with radius f of x and height or width delta x. If we were to sum the volume of these cylindrical disks, then it would give us an estimate of a volume of revolution. As you can see here in these diagrams, by reducing the width of the disks and therefore increasing the number of the cylindrical disks, we gain a more accurate volume estimate. And if we take this to the limit, in effect we are then integrating to find the volume of a solid formed. In the next video we will look at volumes of revolution of solids created by rotation of a curve about the x-axis.